Hello friends, सबको नमस्ते. So today in this video we will create a brain tumor object detection model using a YOLO. For that I have uploaded my dataset in my Google Drive. So I have to upload that zip file of my dataset in a Google Colab. So that for that I have copied the share link and just kept this part. Okay, through this, and when you will run this cell, your zip file will get downloaded, and this is a zip file name. You can see that. See, this is a zip file, and after running this cell, you have to run this cell for unzip that zip file. You can see this is a dataset which contain two folder, test and train. Let me show you. This is our dataset, test, images. These are the images for the test, and these are the labels. Let me show you the label. You can see this is a label. Here one is representing has a brain tumor, and last four values is representing X-min and Y-min. You this two, and this two last two one is the X-max and Y-max as a bounding box detail. Okay. Now you can see that we do not have a YML file, and YOLO basically work with the YML file to represent to know the knowledge of where the dataset is present, where the test folder, where is the trained folder, and where is the validation folder. So we have to create our own YML file. For that, this is a data, path name, train directory, test directory, and validation directory. Number of classes is 1 with number represented by brain tumor. Then we have to create this brain tumor dataset YML file. W is a write mode as a file, and here we dump data, this data, and the YAML file will get created. See this one. Oh, this is a zip file. This one. Okay. So here you can see that this is a data which we want during training by the YOLO model. Okay. And one more thing, that in training, you can see that the number of images which we have is 961. This one, 961. Not 967. So number of images for a training is less. So we have to add data augmentation, means vertical flip, horizontal flip, and other things to increase the number of images. So this is a Ultralytics where from where we can download the YOLO model. So this is a YOLO model. Okay. First we have to load the YOLO model, and the model which we are using is YOLOv9 m.pt. You can see this YOLOv9 TSM and CE. We are using YOLOv9 m, and the number of 20.1 million parameters is this, and this model is trained with 640 to 640 pixel image. After loading the image, we have to train that model on a custom data set. For that, we have to use model.train data. I already told you that basically YOLO work with the YML file. So we have to give the YML file directory. Then epoch will be 5 here, because I already have a model which is 250 epoch. After whole explanation, I will upload that model and show you the result of that model. 640, you already know the size of the image. Batch is 8, means when the number of images divided into batches, I want eight images should be there in one batch. Okay. And what is the use of this is, when you run this cell, you will see that the run folder will get automatically developed or created. Inside a run folder, detect folder is there. Inside a detect folder, one folder is there whose name will be decided by us, and this is the name of that. And inside that folder, wait folder will be there. Inside that wait folder, weights will be saved. Okay. And save true means I want to save the weights file. Save period -1. Here the meaning of that is that I do not want to save weight file for the every epoch. Only want the best weight file should be saved. For that, patient 20 means early stopping, means it will wait for the 20 epoch. After 20 epoch, if the after 20 epoch duration, if the after 20 epoch there is no changes in the accuracy or in the loss, no changes means no decrement in the loss or not increment in the accuracy, so it will stop the training. And validation true, here you can see that we do not have a validation folder, but then also I have used validation true because in YML file already gave that validation. For validation use train images. Okay, now this whole thing is data augmentation, means increasing a number of images because we only have a 957 images. So we have to increase the number of images. For that we have to add data augmentation. So this is random rotation degree, random translation, random scale, random shear, perspective transformation, vertical flip, horizontal flip. So this way you will add a data augmentation in the YOLO while training the YOLO model, and it is quite easy. Now let me run this cell. You can see the training gets started. Not get started, it making the environment to get training started. Now you can see the training now get started. See, this is GPU memory, means memory used during training. It is showing this GPU means 4.120 GB is used for GPU. Bounding box regression loss, classification loss, and this is TFL loss. And see, number of batches we have, 64 batches we have, means 64 into 8, 512 images, 512 images we have. Okay, for training you can see this 5 it's showing 508 or 508 images is present for training. Now this is a function through which I create the bounding box around the brain tumor object. As an object, we create brain tumor has an object in this training, so I have to create the bounding box around that brain tumor. So here it is, where I have passed images bounding box, which is a variable which have a bounding box details, means xmin, bymin, xmax, and bymax. Label means brain tumor here as a string, you can see as a string. And color sample, basically color sample is a list of the colors, list of the colors through which I will select a random color for representing the brain tumor bounding box. Now first I have to create the image copy. Then I have to map int box, because it might be possible that box variable which contain the bounding box detail, the details, or you can say the points value, are in the float value, but I want those values should be in a int, so I have kept here int. Okay, now after that I will first create the bounding box around the brain tumor. Just pass the image, then xmin by min, xmax by max, then the color, and the 5 is the thickness. Then I have to put the label, and label should be below the bottom left corner. I repeat, I want the label should be below the bottom left corner of the bounding box. So bottom left corner of the bounding box, this coordinates we have to pass, xmin and ymax, and plus 40 is adding us some padding below the bottom left corner of the bounding box. So here 1 is a size, color, 3 is a thickness, and this line, and just return the image. Now here you can see that run folder is created by default during training, then detect folder. Then you can see this is a folder name which we have given, and inside that wait folder is there. Inside that wait folder you have seen two wait file, best and last, and we have to use best one. Okay, so this is the best, and you can see this we have to give the test directory through which we retrieve the image and use for the training. These are the color sample list I already told you. Now here it is a file name, it create the list of all the file, all the brain tumor images present in a text directory. Now I have to plot 16 images. For that I want 4 column and 4 rows. Each size will be 16 by 16. Okay. If since I have to plot 16 at 16, so I have to iterate 16 time. Now it will select random file name from this image files variable, and now we have to get the direct image file name directory, whole proper directory. For that we have to use os path name. Just pass the test image directory and the image name, your directory get ready. Now you have to read the image. Now here just you can see that I have passed the image path, not the image. But even you pass the image path or a image direct image after reading, there is no issue. You can do any option. Here I am just passing the image path, and 0 because I am just passing the single image. So to retrieve the information of the image I have to use 0 because only one image is passed. Now, it might be possible that in a brain, multiple brain tumor will be there. So to locate and multiple brain tumor mean multiple bounding boxes. So that's why I have to iterate over the result dot boxes. Okay. Now just retrieve the information because boxes is the dictionary. So box dot x by x by 0 will give me the first image bounding box, first image bounding box details, then a class id. And when I will get a class id, I have to just use mol dot name class id, and my information and my label will get ready. After that just pass those whole things to the draw a boxes function, and you can see that whole process in draw boxes is working with cv2. And cv2 run the image with you can say with in BGR format. So I have to convert it here. See, I have read the images now in BGR format, so I have to convert that into the RGB. So here it's converted into RGB, and just plotation will be there. Now for more clarity, you have confused. For more clarity, let me result dot boxes. Okay. Now just iterate only one time break. Now I think so training training completed. You can see. See, training get completed. We have my 508 all images, and 64 has a batches. This is a losses. Okay. Now let me run this cell. It's already run. Now let me run this cell. So you can see the result uh, when the model is trained with five epoch. First, I have to show that when I will print this result dot boxes, you can see it's a dictionary which contains the results like this. Boxes details will be in X by WH, X by WHN, and you can use any box any box detail you achieve. It's depend on you, but I want X by X Y as a detail, so I retrieve that. You can see id. I can class is represented by this and class id is represented by this. I can retrieve information through this. So now let me commented this. Now let me run this whole for 16 iteration. When the model is trained with 5 epoch. Something error. What is the error? Image with boxes is not defined. Oh, mistake. Image. Let me run this. Now again let me run this. See, brain tumor, brain tumor, brain tumor, brain tumor. This way it's shown the result, and label is below the bounding box. Now let me upload the model which is trained on 50 epoch, and let me show. Okay, let me come back when the uploadation of my model get ready. Okay, so the uploadation is completed. Let me show the result of the model, YOLO model, which is trained on 50 epochs. You can see result. Okay, multiple bounding boxes, multiple brain tumor. Somewhere the accuracy is less, but you can increase the epoch, or you can say increase the augmentation, and you can see there is a better accuracy or better result. Okay. So this way, this is a training of YOLO model, YOLOv9 model on a custom dataset of brain tumor to detect the brain tumor in a brain image. So this is all. I have explained you everything. So please like, share, and subscribe. Thanks to all.